Okay, today we're going to find limits analytically. Before we found limits numerically by plugging in numbers into a table of values, or graphically by looking at the graph. Analytically, it's when we're using our algebra skills or other skills, trigonometry, to find our limits. So we're going to evaluate a limit using limit properties and evaluate limits by dividing out and rationalizing. These are two main ways in order to do that when we run into trouble. You'll know trouble when you see it. But a little review first, some factoring review. Hopefully you've seen these before. Difference of squares, most people remember. If I have a difference of two squares, it's just the square root of each of those. One of them addition, one of them subtraction. There is no formula for a sum of squares if we're factoring. We got into Algebra 2. Recalculate. We did some difference of cubes and sum of cubes. This is how we factor those. And there's a way to remember these, or you can just memorize it and move on from there. When finding limits, we're just going to hop into some examples. When finding our limits, we all the same properties that apply to functions apply to limits. Whether it's adding, subtracting, multiplying, dividing, multiplying by a constant, exponents, all that still applies. So when we're looking for a limit, let's say, let's call this. Say we want to find the limit of this function here as x approaches, 2. Let's say x cubed minus 3. Okay. First thing you always want to try, direct substitution. Because most of the time, that's going to work for us. What does that mean? Well, x is approaching 2. So again, a limit is just what our expected y value is. The expected value of this function at that point. So for most functions, I can just plug that directly in. I can plug 2 straight in here for x. Now I'm going to get what I'm looking for. So if I plug that in, instead of x cubed minus 3, I'm going to have 2 cubed minus 3. If I evaluate that, well, 2 cubed is 8. Subtract 3 is going to be 5. There we go. The limit as x approaches 2 of x cubed minus 3 is just going to equal 5. Direct substitution is going to work more often than not. Okay? You try a couple of examples now. You try this one. The limit as x approaches 2 of x squared minus 3x plus 4, all divided by x plus 2. Pause it, work that one on your own, try the direct substitution, see what you get. Okay, so if I directly substitute 2 in here, we should get 2 squared minus 3 times 2 plus 4 over at 2 plus 2. Now, we can do some of this in our head, I hope. 2 squared is 4. If I subtract 6, that's a negative 2, and a 4 is a 2. 2 plus 2 is 4 over 1/2. Limit of that function as x approaches 2 is 1/2. Let's try another one. Limit as x approaches negative 3 of 4x cubed. I should have parentheses around these. That one. This is all considered one term in a fraction, not as big a deal. 4x cubed minus 5x plus 1. Try that one. Plug in -3. Well, it's going to be 4 times -3 cubed is going to be a -27. Minus 5 times -3 plus 1. And you got to do this exponent before you multiply. 4 times -27. What is that? -108, I believe. Check your calculator. That'll be plus 15 and plus 1. Or it's like a -92. Okay, so direct substitution is going to work just about all the time. Now, there's a couple cases, a couple times when it doesn't work. Let's take a look here. Try this one. Try, okay, number 4. Try this one. Find the limit as x approaches -2 of x squared plus x minus 2 over x plus 2. Okay, pause that. Try that one, see what you get. Okay, if you do direct substitution here, if I plug in -2, -2 squared is going to give me a positive 4, plus a -2 minus 2 over -2 plus 2. Well, that gives me 0 over 0. Newsflash, 0 over 0, that's undefined. That is not equal 1. Okay? If I get 0 over 0, that's bad. But it's key. It's also good. 0 over 0 tells me there's something I can do to this. This right here, when I get 0 over 0, this is called the indeterminate form. Indeterminate form. Zero over 0, indeterminate form. Okay? When I get that, doesn't mean I've done anything wrong. It means I need to go back and do something different. I can't just do direct substitution. So, I'm going to take a look here at my function here. I'm going to start back over. The limit as x approaches -2 of this here. Well, things you want to try. If it's a polynomial like this, you want to try and factor. X plus 2 isn't going to affect. But this numerator, well, I've got a trinomial. It's a quadratic. I've got a constant of -2 or -2. So remember, in factoring, I want to try and find the factors of -2 that add up to a positive 1. This is where having strong algebra skills and being able to factor quickly comes in handy. My leading coefficient here is 1, so I don't need to worry about a box or any sort of factor by grouping or any of that. I can hop straight to here. Factors of -2 that add up to 1, well, they're going to be a positive 2 and a -1. Okay, so now what I've got here, I end up with a pair of factors that can cancel out. I can divide these factors out. At this point, I can divide that out. And now I end up with, well, the limit as x approaches -2 of just this function, x minus 1. Now I can do direct substitution, and I don't get my indeterminate form. It's not something undefined. Now if I plug in a -2, it's the limit. It's -2 minus 1. It's just going to give me -3. That's what my limit is. So, whenever you get indeterminate form, we're going to try and factor out. Factor out if we can. Divide that to factor. Write it out. Okay. Another possibility we might need to encounter, we need to take care of, is rationalizing. If you think back to geometry, we had something like, even pre-calc, we'd have like 3 over radical 2. We would have to rationalize that. To do that, we took it times radical 2 over radical 2, and we get 3 radical 2 over 2. That's rationalizing. Now, for our purposes, a lot of times we may need to rationalize the numerator. We've always been used to rationalizing the denominator. Now we may need to rationalize the numerator. So let's look at something like this. Let's find the limit as x approaches 0, around 5 or 6, I don't know. Limit as x approaches 0 of square root of x plus 4 minus 2 all over x. Always try direct substitution first. If I do that, I'm going to get the square root of 0 plus 4 minus 2 all over 0. Well, that's not good. Notice this minus 2 is outside of the radical. The plus 4 is inside the radical. The square root of 4 is 2. 2 minus 2 is 0 over 0. 0 over 0. Indeterminate form. We can't keep it like this. We need to go back and try something else. So we're going to rationalize this guy. And remember, when you rationalize, especially if it is a binomial like this, square root of x plus 4 minus 2 over x, you're going to have to multiply this times what we call the conjugate. Remember the conjugate? Square root of x plus 4 minus 2, its conjugate is the square root of x plus 4 plus 2. A lot like our difference of squares. The reason I do this is because when I FOIL this, or when I distribute these and multiply them out, stuff's going to cancel. But I can't just multiply by that. I have to multiply by the same value on top and bottom. Because if I multiply by a fraction, the same thing on top and bottom, this fraction here in black equals 1. Multiplying anything times 1 keeps it the same. Okay? So now when I FOIL this, well, radical x plus 4 times radical x plus 4 is just x plus 4. Yes? Yes. Okay? And what? Okay. The middle terms will cancel. I'll have radical x plus 4 times 2 and minus 2 times radical x plus 4. They cancel out. Here I'm going to end up with, and lastly, minus 2 times 2 is minus 4. Now on the bottom, you might be tempted to want to go ahead and distribute this and multiply it out. You won't need to. Let's just leave it as x times square root of x plus 4 plus 2. Good idea not to multiply that at this point. Here's why. If you do that, well, we're just going to factor it out later anyway. Okay. Now I've done a mistake here. I've missed something. I haven't done my substitution yet, so I need to make sure I keep writing. In order to keep it equal, I've still got, this is still the limit as x approaches 0. This right here. Okay, now I want to simplify up anything I can here. Well, I've got x on top and plus 4 and minus 4. Plus 4 and minus 4, those are opposite, so they cancel out. So I still have x on top over that denominator, x times radical x plus 4 plus 2. And now I've got an x on top and an x here. Since that's multiplied by that, that's a common factor. I can cancel those. All right? So on top, well, you can't have a topless fraction. If I cancel those, I still have a factor of 1 up there. And on the bottom, I've got this left over, the square root of x plus 4, and then plus 2. Now I can do my direct substitution. Now if I plug in 0, I don't need to keep writing the limit now because I'm substituting. I'll have 1 over square root of 0 plus 4, and then plus 2. Well, square root of 0 plus 4 is 4, square root of 4 is 2. So this is 1 over 2 plus 2, or 1/4 is our limit there. Rationalizing or factoring. Those are the quickest, easiest ways to figure out how to take care of that indeterminate form. Okay. One other thing to show you, there are some special functions. There's lots of theorems listed in your book. I'm not going to go through all those. If you want, you can look at those in section 1.3. Pretty much just dealing with properties of numbers, like I say. They're true for theorems as well. But 2 special trig limits. You can write these down. You don't encounter them very often, but certainly it's helpful to know them. One, again, these are also in your book. The limit as x approaches 0 of the sine of x over x. If you think about this, if you plug in 0 here, well, the sine of 0 is 0. 0 over 0, well, that's our indeterminate form. But I'm not going to be able to factor anything here, nor am I going to be able to rationalize. So what I've got to do is just set that, or this is a special, that's why we have a special limit here. This is equal to 1. Another special limit. Limit as x approaches 0. 1 minus cosine of x over x. That one is equal to 0. Pause that, copy it down. And here's your assignment for the night. Okay. Try those. Give some of those a shot. Once you have questions on them, we can work on in class. There's a lot of algebra review in here. Good luck.